In this video, we're going to look at running an existing workflow from file using Mia's processing view. After loading up Mia via the Plugins Modular Image Analysis menu item, processing view will be displayed by default. If you don't have the Modular Image Analysis menu item, it's likely you still need to install the plugin. For more information on doing this, you can check out one of our previous videos. Processing view is a simplified view designed specifically for loading pre-configured analysis workflows. These workflows can be created in Mia's editing view, but we'll be covering that in an upcoming video. Mia workflows are stored with the .mia extension and contain all the relevant information to run the analysis on a different computer. The example workflow we'll use today comes from our Mia examples repository, which can be found at github.com/mianalysis/Mia_examples. There's a link to this in the video description. To download the example files, click the green code button, then go to Download Zip. All you need to do after this is just extract that out to a single folder. So here's the folder I've just downloaded and extracted, and within this I'm going to the EX1 nuclei segmentation folder. Inside this we've got a couple of input images that we're going to be using in the analysis. These are just 3D stacks showing fluorescently labelled nuclei. We've also got the workflow file, so this is the one ending in .mia, and this one's going to tell the plugin how it needs to be operating. And then finally, just for your benefit, we've got some example outputs so you can compare what you get from it with what we would actually expect to receive from it. In this case, what the workflow is going to do is it's going to output an overlay image, one per input stack, and this shows the 3D detected nuclei color-coded by their longest chord. So this is one of the measurements we're going to be taking, and in this case it's the furthest distance between any 2 points on the surface of the nucleus, as well as a unique ID number within that image stack. And that relates to the Excel results spreadsheet that we also get from the workflow. To load our workflow, we just go to Load and then select our .mia file. At this point, all the available parameters should be displayed. And depending on how the workflow is being configured, this is likely to just be a subset of all the parameters that are actually contained within that workflow. You can see all parameters by going to Editing View, and if you select a module, you'll see that there's many parameters that just aren't listed on Processing View. The intention here is that the visible parameters in Processing View are only those that need to be configured on a run-by-run basis, so cover options such as the files or folders to process, optional filters, and visualization settings. In this instance, there's a file selector, and you can see that this is currently listed in red, and if I hover over this, it will show us the path to the image that it's trying to load, and that doesn't match up with our current path. So if it's showing up in red, it means that it can't find that current file. So we just click on this button, I go to desktop, load in the file. And at this point, I can either select an individual image, so select that one stack, or you can also just put yourself by default into batch mode by just selecting a folder. And when we're in this batch mode, it's going to identify any images within those folders which match up to certain criteria set within the workflow. So in this case, the parameters, which are again edited via Editing View, it has to be a .tiff, and it can't have the name underscore, can't have a name containing underscore overlay, because we know that's going to be our output, and it prevents us accidentally reprocessing the output images. The next thing we've got is a volume filter. So this is just going to let us set the size of our accepted nuclei. So this is the minimum size they've got to be. In this case, you can see that the little power icon here is showing up in green, and that's because this is optional. So we can turn that on and off. See, when it's off, it's got a little strike through. And then the final two settings here control that output overlay image that we've seen earlier. So when show image is displayed, it's going to appear in real time as it's generated. So every time you process an image, that output image is going to be displayed on the screen. And that's fine if you're processing maybe 1 or 2 images, but if you're in a big batch mode, I'd probably turn that off, because otherwise you're going to be inundated with images popping up. The second option here, save, will just save that to the same place as the input file. So in this case, it would be here, underscore, overlay, and I'd recommend leaving that on unless you have a particular reason you don't want the outputs being saved. To run our analysis, we just hit the run button and wait. As Mia processes our file or files, the progress bar will move along the bottom of the interface. For single file mode, this will be a verbose output telling us what individual steps it's doing, whereas for batch mode, it just tells us how many jobs have completed. In batch mode, you can click this to enter the same verbose mode as you would have had with single file mode. Because we have the show image option enabled, we're getting these images displayed in real time. So as before, these just show the nuclei color-coded by one of their measurements, in this case the longest chord, and with a unique ID number superimposed on top. These images are automatically saved into the same folder as the input file with the suffix overlay. Irrespective if you're in single file or batch, these images will always be saved with the same name as their input file. On the other hand, your results file, your Excel file, is either going to have the same name as the input file if you were to select one, or if you were, like we have here, be in batch mode, it will have the same name as the input folder. The Excel spreadsheet contains multiple sheets, typically with one for each object type, as well as an optional summary sheet and a couple of record-keeping sheets. In the current example, we show all the possible outputs. However, for a usual analysis, only the measurements of interest will be exported. We'll go into more detail on configuring this Excel spreadsheet in an upcoming video. As well as the main parameters panel, Processing View also provides additional information panels which can be turned on and off from the View menu. First up is the file list. This shows the status of all running jobs and is especially useful when batch processing multiple files. Additional columns can be enabled by right-clicking and selecting them from the drop-down menu. These can be dragged, expanded and sorted by again clicking that top menu. There's also a help panel. This shows the information about the actively selected module. So to select a module, just click its name here and it will give you a description of that module as well as the summary of every single parameter available in that module. So not just the parameters selected on the processing view, but everything that's running behind the scenes. Finally, there's a workflow-specific notes panel. This provides an editable text box that can be used by either the workflow creator or end user. For example, the workflow creator may wish to leave advice on module parameters to the end user, or similarly, the end user may just wish to keep notes about which parameters work best. Any changes to the notes, or indeed parameters in general, can be saved to the .mir workflow file by clicking the Save button, which will update the original file, or to save the updated workflow file to a new file by going to File, Save Workflow As. As always, thanks for watching this video, and if you'd like any more information about the Mir plugin, please go to mianalysis.github.io or check back here for upcoming videos.